So welcome everybody to the second day of the symposium, Face It, the New Challenges of Cognitive Visual Semiotics. This morning, we have the pleasure of having with us Anna Skarpelis of the Social Science Center of Berlin, who will talk about when is a face, data augmentation, partially synthetic data and their moral and ethical consequences in artificial intelligence. Anna is a cultural and comparative historical sociologist utilizing qualitative and computational methods in her research on race, social classification, violence, and artificial intelligence. So Anna, I leave the floor to you for 30 minutes, and then we will discuss.
Perfect. So let me share my screen. Okay, and I'll keep all my sound on my laptop off. That's correct, right? Yeah. Okay. And I'll also leave my camera off because my laptop is a little bit slow, but given that most people are here. So first of all, thank you so much for the invitation, Maria Giulia, Massimo, and Claudio. It has been such a joy to be here for the past day. I've learned a lot, especially as a comparative outsider or a newcomer to semiotics. And so I wanted to actually situate my work very briefly in relation to some of the things that have been said to kind of point to some commonalities from some of the talks yesterday. So what I picked up on, especially in the introductory lecture, and where I see big commonalities between the study of semiotics and what sociologists are doing, especially cultural sociologists, are questions about thinking about how meaning is generated through difference, to think about different sorting mechanisms. And so when Maria Giulia was talking about thinking about maybe force or vortices as sorting mechanisms rather than studying images, for example, through saturation, as you would do in a kind of more classical analysis, I was thinking there's actually quite a lot of similarities to the sociology of culture, where we're thinking about how we can measure meaning. Massimo, of course, when he was talking about morphology of search engines and about this kind of holistic understanding of singularities, we're also trying to get out of these kind of more narrow ways of measuring things. And so there's big overlaps there too. And of course, Claudio's questions are traditional, like STS question, right? What is truth? Who gets to say this? Who are the gatekeepers? What are the standards by which things are adjudicated? So my larger project that this is a part of, and really the kind of final chapter of my book, is about how race gets located in the body. So it's called Racial Vision, Failed Projects of Human Difference. So it looks at history from the 18th century, especially starting in enslaving nations, when race becomes a very important criterion for differentiation. And it looks at how scientists and the state are starting to locate race in the body. So these projects, so look at the practice of scientists and of states, and at the cultural objects that result from this. So this has to do, in some senses, with discrimination, of course, because it's a history of violence, it's a history of discrimination. But I'm mostly interested not really in improving systems that contain bias, as the kind of algorithmic justice literature is trying to do. So my goal is not really to de-bias, but to look at these forms of scientific practice and how they continue to exist through various iterations throughout centuries. And I look at how bias and discrimination is generated over time. So it's not so much a reformist aim that underlies the project. It is more an attempt to understand how discrimination can be with us century after century after century. And so today's talk is called When is a Face, Data Augmentation, Partially Synthetic Data, and Moral Ethical Consequences in AI. So I want us to look at this image that I put up. So there's four photographs on the slide, right? We can see the photos of one woman and three men. They're portraits taken from a fully frontal perspective. I haven't told you who these people are or where these photos are taken, but you can infer certain things from the photographs themselves. The people are looking into the camera. There's no occlusion apart from the microphone a little bit. The people look reasonably made up. They're attractive, they're young, they're smiling. So it's likely that these photos were taken with consent and that the people were posing for the occasion. But there's also differences between the photos of race, of gender, well, what would be called race in the United States. So what we're dealing with in these photographs are 4 photographs out of a data set of about 20,000 people that was created in order to improve machine learning frameworks for facial recognition. And the woman here has been classified, and I use the researcher's own terminology throughout, as quote-unquote Caucasian, the man underneath her as quote-unquote African, the one underneath as Asian, and the 4th man of Indian. So far, so usual for computer vision practice and the annotation of images and their slotting into discrete classes. Here, race, at other times, gender or age. But if you treat if you treat this next set of images as a matrix and move along from kind of left to right. So on the very left, the first column is a column that we saw before. So we see that each of the person's likenesses has been modified. So again, in the language of the researchers who produced these images, the woman's face has been translated by means of a machine learning framework from Caucasian into a different racial category, African, Asian, Indian. And the same happens for everybody else. So there are these forms of quote unquote racial translation. So the translation of the woman into her own class, Caucasian into Caucasian, renders her even whiter, just like the translation of the quote-unquote African man renders his skin tone darker, his lips plumper, and his nose broader. But most egregious, really, to our sensibilities, may be the very act of translation from one race to another in and of itself. So historically, race has been a category of state practice and enumeration that has been used to subjugate populations and justify their exploitation. Of course, race remains a relevant category in the United States, for sure, of practice today. So if you think about categories like affirmative action, racial classification remains a meaningful criterion for social differentiation. So race today, of course, is for the most part understood to be a pseudo-scientific category. So people don't think that there's any real biological grounding in it, but also one that is immutable and unchangeable. So you don't change race over the life course. You might change gender, although there's also discussion about what language you should talk about there. But with race, there's this agreement that it's immutable. So that is one of the very few social categories that is presumed to be stable over the life course. So what is unusual here is this idea that a person could change race. Societies are in the business of being terribly awkward about race, but also very serious at the same time, as we've seen in cases of racial trespassing, like Rachel Dolezal, where people pretend that they belong to a racial minority group for a benefit. So this question of racial translation, or what I call racial metamorphosis, really should not happen. And in the rare cases when it happens, it's socially sanctioned, especially when it's found to be a deceptive practice. So bearing all of this in mind, when you look at this matrix of people, the matrix of images becomes confusing, even paradoxical. It raises the question of under what circumstances this morphing between ascribed categories could become permissible or even desirable. So the obvious question here is to ask, well, what possible real-life scenario or social problem could motivate this technological solution? Why did computer vision engineers turn white people black, Asian people Indian, etc.? And to follow up, the kind of broader sociological question is, what can this case tell us about how AI is reorganizing the social? Or differently, does, and if so, how, this shift from analog to digital alter the ways in which the world is made out? So it's important to me to ask both questions jointly, because buying into the self-declared logics of engineers risks accepting and naturalizing the narratives as legitimate normative concerns. And it's precisely kind of the gift of kind of critical social science and critical humanities to contest our interlocutors' narratives, especially when it's about scientific practice that has immense social consequences. So let me give you a quick overview over the structure of the talk. So first, I will deliver on my promise and tell you about the motivations behind the racial translation paper. So why do people think this was a thing that should be done? Then how are these missing people restored? So the problem is missing Black people from computer vision training data sets. And lastly, what are the implications for what a person is or becomes as a consequence of being datafied? So the photo I began with, the matrix of photos I showed you, is from a 2020 paper by a group of Chinese researchers led by Jianchong Ge and his co-authors. So they identified a salient social problem in facial recognition, namely that there's a strong bias on recognition accuracy in these systems. So this is because, as algorithmic justice scholars have shown, biased training data leads to super biased outcomes. So to give an example from the realm of policing, the lack of equal representation of faces of non-white people has led to their misclassification. And so this has meant that in several cases, innocent Black men were falsely arrested by the police because software told them so. So the Chinese researchers jumped on this question of bias and decided that one might be able to fix racial and ethnic distribution imbalances in machine learning by generating more images of non-white persons. But because they saw collecting new data, as in like taking photographs in the wild, so to say, as too expensive, their proposal was to generate new images from existing ones through a class of machine learning models called generative adversarial models, or GAMs. So GAMs, as you know, create new images that look real and reflect the underlying statistical distribution of the training data, but they're not real in the sense of representing people that exist in real life. And we had some example yesterday during the talks. This person does not exist.com and so on. And so in our case, we're dealing with a particular subclass of GANs so we're not dealing only with the creation of entirely synthetic data, but with a combination of generation and augmentation of really existing faces, and then their translation from one race to another. So data augmentation, and this is kind of a particularly very representative example of how computer vision engineers illustrate the sometimes nefarious projects they engage in, usually with kittens or dogs, although the real life applications tend to be a little bit more problematic. Anyway, so this is taken from a research article about how to do data augmentation. So this is usually performed when there isn't a sufficient number of training images, and you usually perform minute modifications on the existing photos. You rotate them, you stretch them, you change the color, you introduce occlusion to the image, which is called data warping. But you can also create synthetic data from existing data, as in the case of generative adversarial networks. So this is referred to as synthetic oversampling. But data augmentation through domain translation is rather unusual. And so we might call the kind of resulting people racially augmented Franken people in some sense. So by now, you're probably wondering who the source material for these augmented people are. So the researchers in the paper I described use as source material a fairly innocuous dataset called the Microsoft Celeb dataset. It contains 1 million photographs of famous people of various races, demographics. And from that database, the Chinese researchers generated a new and awkwardly named racial faces in the wild dataset. So what they do is they annotate themselves and they divide the images into 4 subsets that they come up with the categories themselves. And these categories are quote unquote Caucasian, Asian, Indian, and African. So the labeling, of course, is done by humans. And in the process, a number of impactful choices are made. For example, they say, well, if a person is maybe racially ambiguous, we kick them out of the data set. So we only, so the people who are put into these categories are people that become legible to Chinese researchers as people belonging to one of the 4 categorizations. And of course, this omission of data is super meaningful because it artificially generates a set of legible and unambiguous phenotypes, which misrepresents an already skewed population of mostly actors, who tend to be whiter, more symmetrical, attractive looking than the regular population. So do note that kind of in this process of trying to balance skewed data sets, we are tending towards prototypical and ideal cases. So in this process of trying to compensate for missing data, we are really engaging in a transformation of the underlying statistical distribution of the world population, and we're skewing it further. So this attempt to de-skew leads to new forms of skewing. So there are some implications of this. For starters, we can make the obvious observation that a set of cultural values and biases inform image annotation and thus impact class labels. Who's Black, who's white, who's other. So in short, who is considered suitable for training set inclusion in the first place? But the case of data augmentation, where different racial domains are transferred to one another, goes a little bit further than this point about human bias and annotation. So it extends the fundamental idea of data augmentation that the authenticity of the image no longer matters as long as there's statistical efficiency into the realm of ethics and power. And so consequently, in the model as is, the question of racial metamorphosis or transition becomes deproblematized as long as the resulting output efficiency warrants the process. And statistically speaking, the newly generated partially synthetic data works super well, say the researchers, at least. It misclassifies Black and brown faces at much lower rates than algorithms trained on other data sets. So our Franken people's racial metamorphoses succeeds at reducing bias, it appears. But of course, we should remain vigilant and interrogate what the computer vision engineers are doing. So if we shift our focus from these questions of technicality, of robustness, of optimization, and ask, well, how come that there are unbalanced training sets in the first place? We open ourselves up to more interesting questions. So for example, why is it that one of the most surveyed groups in American society is also the least captured in training sets? So in order to understand this, I set out to understand what computer vision engineers all day. I'm a sociologist after all, so what they do is, I study how knowledge is created, and so I went into the web of science and decided to compile a data set of most publications relating to biometrics and race. And so I'm in the middle of a meta-analysis of the scientific output in journals on biometric artificial intelligence and computer vision. So I collected a bunch of articles. In total, it's a couple of thousand, and I'm in the process of analyzing them. And I'm trying to understand how do computer vision engineers construct these racial categories? Is there an agreed upon definition, or do they just kind of make it up as they go? And what do they measure? And so first of all, what you can see is that, this is since 2016, there's a ton of output on this, a ton of interest and a ton of research. And this doesn't necessarily make it into the media, but but it is there. And a lot of this research is being done outside of the United States at fairly small universities. And so again, for example, in the United States and Europe, it wouldn't become part of the computer vision or computer science curriculum, but it is a very active area of research. And so what I was looking at, I found, unfortunately, computer scientists almost never engage with the literature, the humanities, or social sciences on race. So when I was trying to understand, what do they do and how do they do it? Most of the articles say, race is a weird concept. We went into Wikipedia and there's no agreed upon definition about what that is. It seems to be a social construct, but also people look quite different. And so, we kind of have this ad hoc definition of what race is. It's some kind of visible criteria. So these ad hoc categories either serve as specific interests of the researchers in that particular project, like ethnic identification and surveillance, or they depart from the specific characteristics that the training data have and then construct the categories based on that. And so machine learning, of course, and computer vision has undergone many transitions over time, especially since the advent of deep learning. And so this graph from a survey paper represents just some of the transitions that have been taking place since the 1990s. I'm not going to go into details about the specific technical aspects of it, but the kind of meta point is if we look at these transitions in techniques of racial representation for recognition, we see a shift from holistic approaches of the 1990s, like eigenfaces or Fisher faces, to the use of carefully handcrafted local descriptors that relied heavily on edges and filtering, especially Gabor filters and local binary patterns. And in the 2010s, we're finally moving to deep learning approaches and semi or unsupervised approaches, where the performance of previously unclassified images improves super rapidly. What's not represented in this graph, or the one before, but what I want you to take away is that they locate race and establish salience in rather different parts of the face. Sometimes based on racial landmarks initially, sometimes in less interpretable regions. So to sum up from this kind of cursory overview, or first deep dive into, first superficial dive into this vast literature, what we can take away is that there's no field-specific agreement on what race is, how to measure it, just that the face is a privileged region on the human body where race can be identified. And it's not about color, skin tone, which is interesting because sociologists always measure skin tone. So if you look at how surveys work, social scientific surveys, they always measure skin tone as a main aspect that differentiates people, especially in the United States. But here, skin tone really doesn't matter. It's all about facial features in the face. And so let me zoom out and return to the questions I posed at the beginning. So why did the computer vision engineers turn white people black? And what can this tell us about how AI is reorganizing social? So the first question can be easily answered. They want to balance data sets and improve classification accuracy of machine learning frameworks, and they succeed. Great. The second question is a little bit harder to tackle, and I want to focus on just 3 possible ways of answering it from the perspective of historical continuity and change. So like what is changing in this transition from the analog to the digital? The second part is the transition from the analog to the digital and the implications for the category of personhood. And so this is again where the sociology person comes in. What does this mean for subjectivity, for the construction of the person? And so, of course, the moment we discuss questions of categories and data and think about, it serves us well to think about these from the perspective of materiality of data and its infrastructures. So Livmanovic, who came up yesterday already, called the database the major cultural form of the 21st century. And we could spin this claim, of course, into an argument about novelty and innovation, about the speed of data, etc., about an unprecedented form of datafication that fundamentally changes how the category of a person is constructed. But as any historian is quick to remind you, things we believe to be new and transformative really rarely are. So the media studies scholar Estelle Blaschke, for example, showed that image annotation is not a practice that arose with digital image, but it's actually quite old. And it preceded it in the form of hand captioning. And we, of course, also know from histories of surveillance and criminality that tabulated forms of data have been with us for centuries. And sociologists of technology and American studies scholars have engaged with these complex histories of how race and technology intersect. And I merely gesture at the research here in order to come to some tentative conclusions. So what was interesting to me when I was looking at what is happening in these attempts by computer vision engineers to fix what race is and to measure it, is that there is, of course, this ethical and moral distance to the populations. So matters of consent and ethics in the production of the photographs is not really considered by engineers for the most part. But what also struck me is that there's this, in addition to this ethical and moral distance, there's also really a thinness of the data or distance from the person. And this might be perplexing at first, because the moment we talk about AI, we talk about big data in the sense of a lot of input, right? So we think there is a thickness to data that didn't exist before because of the affordances of technology. But this thinness, I would say, is further exacerbated by another kind of distancing, that of a representation really of the object. Because computers cannot usually work with the real life object of the human face, thankfully. It works with a representation of it, so 2D image, right? So you take a digital image and then you analyze that. The image becomes decomposed into vectors and then you take it from there. So the input is a representation of a real world object that operations are performed on. So the representation of the face, rather than the face itself, acquires an outsized importance, and the real life object is reduced to mere data input. So everything necessary for an analysis and establishment of race has to be contained within this representation rather than person. And the real life counterpart has no capacity to supplement, to speak back, to utter, what they think about, how they self-identify. So of course, this has obvious consequences for a multimodal construct like race. And my colleagues who work in the private sector, but are trained sociologists like Alex Hanna and so on, who work on algorithms and ethics, have pointed this out, right? That you have a multimodal construct like race, it's constructed and compressed, and that has obvious consequences. So the kind of conclusion from this is that computer vision technologies, in a sense, are more data poor than earlier technologies of racial persecution. So my expertise during my PhD, I worked on racial assessments in Nazi Germany. And so when you look at the historical ways in which German Nazi bureaucrats conducted racial assessments, these included not only photographs, but also what historical interlocutors would have referred to as quote unquote holistic assessments that included interviews, genealogical surveys, self-definition, and so on. And so the point that I want to make here is that in this transition from analog to digital, that does not necessarily lead to an expansion in the richness of data. So we have like an actual focusing and a kind of thinning of data. And last but not least, I kind of want to close by thinking through some of the implications AI has on personhood, on what it means to be an individual when seen by and through technologies. So the ways in which states and scientists create people through processes that philosophers like in hacking have called making up people are deeply consequential, even if the people so categorized do not share or consent to the classifications that are imposed on them. And so the case of these Franken people, even if meaningful within broader socio-technical systems, is very rare. But the thinning of how racial meaning is assigned should be worrying to us. It generates new social categories that strip those who are classified as such of their histories and experiences. It reduces them to phenotype, and in the process creates new forms of differentiation that may reflect real-life differences even worse than ordinary demographic forms of ethno-racial classification that we use in surveys, for example. Let me close. I've spent the talk so far focusing on an empirical case that deals with long-standing histories of state power and surveillance. Of course, digitalization impacts much broader parts of society and is not uniquely good or bad. We know cases of political polarization as an outcome of an increasing use of metrics in journalism, job losses due to automation, the use of digital twins in biomedical situations, and so on. But what the specific case of making up people in facial recognition showcases is the potential really of the social sciences and the humanities for studying AI in a kind of holistic manner, in a way in which I think STEM fails to do so. And so, on the micro level, we can kind of study AI as a mode of analysis in which we unblack box opaque socio-technical systems, whether this is for critical code studies, looking at the materialities of data. And this will really allow us to understand what kind of knowledge creation AI-based approaches permit. On the meso level, we can look at local and organizational instantiations of AI. And so differently, we can look at AI as an organizational site for the exercise of expertise and the creation of professional vision. And I guess more globally, we can treat specific instances of AI as a complex socio-technical system that shapes social categories and therefore acts back upon the world. And of course, because I'm a sociologist, I have to close with, this kind of like broader macro assessment of it. But yeah, I think I will close with this. How's the time? So,
you have 2 more minutes.
2 more minutes. I think I will donate them. It's all over. Thank you very much.